Okay, we're talking conductor fill using different size conductors. Okay, there is a different procedure for different size conductors versus same size conductors. All right, different size is more complicated, but it's not that bad. All right, so we're going to go to chapter 9. Hopefully, you have your code book in front of you. We're going to go to chapter 9, which is a bunch of tables in chapter 9. We're going to look at table 1. All right, so this is the percent of cross section of conduit for tubing and conductor cables. This is what percentage you can fill them. All right, if you have only one conductor in a conduit, you can fill it 53%. If you have two conductors in a conduit, you can fill it 31%. Now that may not make sense to you. Why only 30%? Why can't 31? Why can't you go 50%? Well, you got to think about it. If you had two cables, each of them was half the diameter of the conduit, they would get jammed in there. Okay, so it's 31%. It is what it is. So you use 31%. And then over two, which is probably the one you're going to use if you do get one of these questions. I don't anticipate you getting one of these questions, but we need to be prepared for it. So if it's over two conductors in that raceway or that uh, conduit, you can fill it up to 40% of the cross-sectional area. That's what that table is all about. It's not real complicated, but you'll see how that comes into play as we look into the conduit tables. All right, so here we go. Now there is a lot of notes. Boy, oh boy, oh boy. If you get really into the weeds on this thing, you could read every single note, and boy, by the time you got finished, whew, your head would be just full of a lot of information you don't really need to pass the exam. I'm all about passing this exam. All right. What happens when you get out in the field is, it's probably you're not going to be doing this stuff anyway, more than likely. But, all right, pass this exam, we're going to make this happen. So I have only highlighted them. We're only going to talk about the ones that you're going to need to pass the exam, all these notes. Okay. So, first of all, note number 1, see Annex C for the same size. So, remember, we're doing different size, all right? So, note 1, we're going to go to Annex C. Now, we'll do this later in another video, but we're not going to do this right now. We're just going to, that's note 1. Okay, now, 2 and 3, I don't think are all that important. So, note number 4, this is important. The maximum of 24-inch length nipple is permitted to be 60%. Remember that table? It was only 40% you could fill with more than two conductors. All right, well, guess what? If it's a nipple, if it's less than 24 or if it's up to 24 inches, you can actually fill it 60%. And that's kind of obvious for obvious reasons. You're not going to be, you don't have to pull that wire, very far. You just got to go maybe from your service to your main panel, and it might be 6, 8, 10 inches or whatever. And so you can fill that one 60%. A lot of questions like this, they're going to say, when they say maximum of 20 or more than 24 inches, they'll usually use the term more than 24 inches. You have to realize, okay, now we're probably talking about conductor fill. But they might also be talking about these adjustment factors. Remember we talked about the adjustment factors for the ambient temperature being different than 86 degrees Fahrenheit or more than 3 current carrying conductors, you need to do an adjustment factor. Guess what? You don't need to do those adjustment factors if it is a maximum of a 24-inch nipple as well. So those, by the way, and I don't think I put that in that video, those you don't have to do the adjustment factor if it's a nipple, if it's 24 inches or less. And then once again, for this conductor fill of different size, 60%, you can go up to 60% if it's 24 inches or less. Okay, And then for conductor sizes, we got a couple of tables we're going to use. The conductor sizes is table 5 and 5A, all right? And we're going to use table 4 for the conduit. Okay, table 5 and 5A are the conductor sizes. We're just going to work with table 5. We'll talk about table 5A later. 5A is actual what they call compact conductors, okay? So if they talk about compact, we're going to use table 5A. But more than likely, they're not going to talk about compact. We just have to make sure we use the right table. We don't use 5A. We don't use the compact. We just use 5. If you don't know what that is, think about it. When you have all these, these strands inside of a conductor, there's these tiny little spaces in between these circular strands. Well, if in a compact cable, the actual strands are trapezoidal so that they fit together tighter, and there's almost no space in between the strands, so it's a much more compact cable. But we generally don't use those, but just in case they say compact, you'll know that you're going to use a different table for the size of those particular conductors. Okay, so we have a table 5 and we have a table 5A. We're going to use table 5. That's the conductor sizes. And then there's a table 4 for the conduit. All right, and we're going to look at tables. There's literally lots of tables. They call it table 4, but there's many tables. There's one for each kind of conduit. And table 5, there's different size, different, the conductors are different sizes based on the different insulation. So anyway, hopefully we're on board with all that, and all those other notes. We could really get into the weeds. Like I said, we could talk about all these different scenarios and everything, but they know that your typical electrician is not going to be able to remember all this and not going to be able to answer these questions on an exam. So just to give you an idea, when when I research this stuff, I watch videos, I watch YouTube videos, I watch Mike Holt's videos, and Mike has all these panels of guys who are really, really smart. They're electrical engineers, they write exams for states and what have you, and they will even say that, they keep it simple on these exam questions. They have to, all right? They really only can use one uh, one rule at a time. They don't, on most of these exam questions, you don't have to go to several different rules. It's just one at a time. The exam questions are relatively simple, so I'm not going to get into the weeds. I'm just going to tell you what you need to know to pass the exam. Okay, lots of notes that can get very confusing testing purposes. These are the main ones. Okay, the 24-inch one is important, and these tables. All right, so here we go. So here is the table 4 we're talking about. So there is a table here for each different type of conduit. Flip a page on your in your code book and you can find this table 4. So this is, once again, this one right here happens to be for EMT, electrical metallic tubing. And there's one for each one. Once again, each type of conduit. They're all going to be slightly different inside diameter. Okay, so how do you read this table? Well, we're not going to worry about the metric. This is our trade size, okay, and this is our 40%. Remember that from that table 1? Over 2 wires. If you have more than 2 wires in a conduit, you can fill it up to 40%. And if you look, this is your 100% area over here. You shouldn't need the 100% area, but just for, for interesting purposes, see this 0.304? If you multiply it times 40%, you'll get 0.122. Okay, so this is probably just information you don't really need. But this is a big one right here. This is huge right here. This one right here, and you don't have to worry about your millimeters. So there's a lot of stuff on this table that can be confusing, but we're breaking it down a little bit. Okay, so you got square inches. Now this is your 60% column. When do we use the 60% column? Remember, this is on 24 inches or less nipples. you can fill it up to 60%. Remember, you don't have to do an adjustment factor for the temperature or the number of conductors when you've got 24-inch or less nipple. Okay, so this is our square inches. This is how much we can fill. We can fill up to 0.182 square inches in a half-inch conduit. All right, if we do one wire, this is the number. If we do two wires, this is the number. All right, and then we can, the nominal inside diameter, that might be nice to know. Whatever, doesn't really matter. You're not going to need to know that information there. So, it's not that complicated. All right, so that's table 4, and that's how table 4 works. All right, so we're going to go to table 5. All right, so there's several pages of table 5. This is just the first page. All right, it has the insulation. All right, on this left-hand column, this kind of might look familiar from some other tables that you've seen. You have some insulation on the left-hand column. You have your conductor gauge. This is your gauge in the second column here. We don't have to worry about the millimeters, okay? And then we have this column, which is our square area, our square inches, our cross-sectional area. Don't even worry about this approximate diameter. We don't need to know the diameter of the conductor or of the conductor with the insulation, because they give us the cross-sectional area. They do the math for us. So all we need really is this column right here. The insulation, we read the insulation, we read the conductor size, and we get the cross-sectional area right there. These tables can be very complicated because they put a whole lot of stuff in here that you don't need. All right, so here we go. So let's take it to the next level. So let's say we have 3 number 10s. We have 6 number 8s. The 3 number 10s are RHH. The 6 number 8s are RHW. What is the total cross-sectional area of all of these conductors put together? And then what I want to know is, if it's a 10-foot length piece of EMT, what size diameter, or what number actually, they call it a trade size, what size EMT is needed? Okay, so you can hit the pause button if you want to, and you can see if you can figure out yourself, or I'll walk you through it. So here we go. We look at our table, and we see that 0.437 is the number 10s. The number 10s are 0.0437. 0.0437 is our square inches. So is 0.0437, we have 3 of them, times 3 is 0.141. All right, so that takes care of our 3 number 10s. Then we have 6 number 8s. So we go, once again, this is our RHH and RHW, so we're in the right page here. We're in the right area. And we go number 8, and we have 6 of them. So it's 0.08354 times 6, and we got 0.501. We add those two together, and our total cross-sectional area is 0.642 square inches. All right, and then we take our 0.642 square inches, we take it over to our EMT table. Okay, we take it back to table 4. We find which one is EMT, and we say 0.642. Remember, it's more than 2 conductors. It's longer than 2 feet, so we can't use the 60%. It's more than 2 wires. We're not using 1 wire. We're not using 2 wires. We're using over 2 wires. So we go 40%. We're looking for something 0.642 square inches or bigger. So we start, we go down till we hit a number that's bigger than 0.642. There it is, 0.814 inch and a half EMT is what we need in that scenario. And you thought this was hard. This isn't so hard, is it? No, it's not so hard. You can do this. You can do this pretty easily. So I'm not going to give you any more examples. We'll just, just do some of those practice questions and get familiar with it. And once again, you can always call me, 904-755-4111. If you got a question, I'll answer my phone. My name is Jack Sheffield, Jack the Exam Guy. And remember, you're going to make a ton of money out there once you become an electrical contractor. Make sure that you give a little bit back to people that are a little less fortunate. Maybe give some to your church or pick a charity, and do the right thing out there. Thank you for your business. I appreciate you listening.